Central Washington University. And what we're going to do today is we're going to finish up our graphing, and we're going to learn how to graph the rest of our trig functions: tangent, cotangent, secant, and cosecant. So let's go ahead and get started. All right, we're going to begin, which is a little bit probably backward to what your textbook does, but I like to begin by graphing the secant and cosecant functions. And the reason I want to do these is because we already know how to graph the sine and cosine, and so we're going to use our knowledge of those two functions and the fact that these are inverses of one another to graph these new functions. All right, what I've got here is a table of values for our sine function, and we've already talked about that and found those values before. When our angle theta is 0, of course the sine is 0. When our angle, say, is pi over 3, the sine was square root of 3 over 2, etc. What we're going to do is we're going to graph cosecant. The cosecant is the reciprocal, or the values here are going to be the reciprocals of the sine. So first thing I'm going to do is I'm going to go ahead and make everything a fraction. All right, I'm going to place the radius on my unit circle, which is 1, underneath the 0. The others are already written. I'm going to put a 1 under here, 1 here, 1 here. Oops, missed 1. There you go. To find the value of the cosecant, all I've got to do is flip each one of these. So we're going to save some time, and instead of breaking out the unit circle and figuring it all out, we're just going to take the reciprocal of all these sine values. Now watch what happens here though. My sine at angle 0 is 0 over 1. When my angle measures 0 degrees, is 0 over 1. Well, if I flip that, I get 1 over 0, and as we've talked about in the past, chapter 6, well, you know you can't divide a number by 0, so that's going to be undefined here at 0. Flipping a half, we get 2. Here we're going to get 2 divided by root 2. And I'm going to go ahead and estimate that, and that comes out to be approximately 1.4. Why estimate? It's going to make my graphing easier. All right, here I'm going to have 2 divided by the square root of 3, which is 1.2 approximately. Of course, here when I take the reciprocal, that's 1 over 1, or 1. And then I continue, and notice these numbers are all the same except their signs are changing. So 1.2, 1.4, 2. Now here, flip again. I'm going to have 1 over 0, so undefined. Negative 1.4, negative 1, negative 1.4, and then back up here to undefined again. Okay, over here I added some extra values that we don't normally do with sine and cosine, this pi over 6, pi over 3. Just so we can get a better feel of what's going on with the graph. All right, so here's our graph of the sine function. The first thing I'm going to do is I'm going to take a look at these spots where my cosecant function is undefined. What you're going to place at those positions is you're going to place, let me zoom in just a hair, you're going to place an asymptote, all right, at those spots. So when x is equal to 0, which is going to be my axis, so we aren't really going to be able to see it. But I'm going to have an asymptote right here. At x equal to pi, I'm going to have a second asymptote. And then all the way over here at x equal to 2 pi, there'll be another one. Okay, these vertical asymptotes are going to help me define my function, and I can clearly see just from those two that every pi units I'm going to end up with another asymptote, so I could keep going with this as well. So let me put one more in here just for our reference. All right, now let's graph these points and see what's happening. Well, at 0 it was undefined. At a half, well, I'm going to just have to kind of guess here where a half is. I know pi is approximately 3. So this is 1.5, so a half is pretty much not too far off that axis. All right, so on my cosecant, at that point, at pi over 6, at pi over 6, which is just over here slightly, I'm going to be at 2. That's what I'm graphing. At pi over 4, I'm going to be at 1.4. So somewhere in here. At pi over 3, which is still not quite halfway, I'm going to be at 1.2. Now notice what happens here at pi over 2, halfway. I'm exactly at 1. Now look at your sine function for a second. That's where your maximum occurred on the sine function. On the cosecant function, I think something else is going to happen, but notice those points are in common. All right, going back up the other way, I have 1.2, then at 3 pi over 4 is 1.4, and at 5 pi over 6, I have 2. All right, if I were to graph that, connect those points, I have a curve in which my two ends are going to infinity, and my minimum point now is at 1 for this part of the curve. All right, looking at the other side, I can kind of see what's going to happen here. It looks like I've got these values here, but again, the only point I'm going to have in common with my sine function is right here at this minimum at -1, and then my graph is going to curve downward from there. Same thing here, I'm going to share that point, curve upward, and then here, continue to go down. So I can see that from these functions, by taking the reciprocal, basically this half of the wave is flipping up, this half of the wave is flipping down, to get an intuitive idea of what's going on. All right, so let's try one. Let's go ahead and graph a function. This time we're going to graph secant. Now what we do to graph these is it's easiest to graph what you already know, which is the inverse of secant, which is cosine. So we're going to graph the cosine function, and then once we get that, we'll put in our asymptotes, and then we'll go ahead and graph the secant. Okay, so we're going to go through the same procedure we've done in the past, finding all those numbers for cosine. So ignore the fact you're graphing secant at the minute. All right, so first thing we're going to do is amplitude. Amplitude, number in front, so A is 1/2. Then we're going to check to see if there's any vertical shifting and find that horizontal line we looked for before. Check out the back here. Absolutely nothing back here, so my D is still just 0. There was no vertical shifting. All right, so that's easy. The next thing we're going to find is our B value, frequency. All right, looking at our equation, let's go ahead while we're here. Let's go ahead and make the coefficient of x 1 instead of pi, and then that'll help us answer the phase shift as well. So cosine of pi times x plus 1/3, since I factored out pi. All right, so B is pi. Let's go ahead and find the period. Okay, period we know is 2 pi, let's say equal here, 2 pi over B. So my period is just 2. So everything so far is exactly the same. Now, what I like to do once I get this part of my information, before I bother with the phase shift, I'm going to figure out those increments that we're going up with on the graph in terms of without the shift first, by just taking a look at our period and dividing it up into fourths. So we're going to take and do our increments without a shift. Okay, so again, with sine and cosine, usually we just start at 0 and go from there. So 0, if I divide my period 2 into fourths, I get 2/4 or 1/2. So my next value would be 1/2. 1/2 plus 1/2, 1. 1 1/2, 2. All right, now the last thing we got to do again is that tricky phase shift, that horizontal shift. So let's figure that one out. I've already set up the equation so we can just look at it here. Since I factored out that b, there's my phase shift. It's plus a third, so we are going left 1/3. All right, now this is the part that takes a little bit of time and energy. We got to set up our increments with the shift now. To do that, it's not difficult, but it does take a little bit of time. Since we normally start at 0, and I've shifted left a third, the first thing I have to do is do 0 minus a third, okay, which obviously is going to be at negative 1/3. Then I'm going to repeat the process, and I'm going to do a half minus 1/3. All right, so that's going to be, find me a common denominator of 3/6 minus 2/6 will be positive 1/6. Now let me give you a little hint and a trick that you can do. At this point, you can either continue to subtract a third, subtract a third, subtract a third, which is going to take time, or if you get a common denominator here between these two, we can just count. All right, I'm going to change these to sixth, so negative 2/6 followed by 1/6. Well, what do I have to add to negative 2/6 to get this 1/6? Positive 3/6. So if I continue to do that, I can get all of my other increments here. So 1/6 plus 3/6 is 4/6. And you may reduce if you want to. 4/6 plus 3/6 is 7/6, and then 10/6. All right, easier to count up by 3 every time, or 3/6 every time, than to have to sit and subtract to find those. So once you get the first two, get a common denominator and then count from there. All right, so that should be enough information for us to graph cosine up here, and then we're going to go back and graph our secant. So let's take a look down here. All right, putting in our increments, negative 2/6, and then my next one is 1/6, and then I can just keep going from there. 4/6. Once I get these two in the correct position, then from there we just count on up. 4/6, 7/6, 10/6. And if we wanted to continue to do a second period, we can, just by counting by threes. 13/6, 16/6, 19/6, and 22/6. All right, so we're going to start by graphing our cosine. Let's remember that we start on cosine, we start up at our amplitude, which is this time a half. All right, so we're going to go up to a half and begin. It looks like I've got my marks a little funny here. Here we go. So we're going to start at a half. At the second value, that's our intercept. Then it's our minimum, intercept, maximum, etc. All right, connecting that, and I'm going to connect with a dotted line this time because we're not really graphing cosine. All right, then all I've got to do once I get my cosine graph is my asymptotes are going to fall everywhere there's an x-intercept. So I'm going to go ahead and start graphing, and let me just write that equation down here again. Y equal 1/2 secant pi x plus pi over 3. All right, we're going to go ahead and graph that. Put your asymptotes in everywhere there's an x-intercept. All right, and then remember these minimums and maximums are going to become the vertices of those parts of your secant function. So now all I have to do is use this as my vertex and follow my asymptote. And that's all there is to it. All right, so for secant and cosecant, graph their inverse functions first with a nice dotted line, and then just use those max and min points as your vertices, and you've got it. Okay, the next thing I want to look at, though, is graphing the tan function. Okay, and this is going to be a little bit different. We're going to have to go back to plotting by hand, at least to begin with. Once we get the hang of these, we can shorten it a little bit. All right, there's our unit circle again. And what we're going to do is we're going to find, for each angle theta, we're going to find the tangent of theta using our unit circle. And I'm going to use those standard points again that we used for our sine and cosine. And then we're going to see that probably we're going to need a few more in the beginning to figure this thing out, but we'll go from there. All right, so if you'll remember, on the unit circle, your tangent is sine over cosine. So in this case, 0 over 1, which of course gives me 0. At pi over 4, we have square root of 2 over 2, divided by square root of 2 over 2, which is just 1 for my tangent. Up here, now watch out again, here you've got 1 over 0, so once again, we've got a space where it's going to be undefined, right up top. 3 pi over 4 is going to be same values, 1 is negative, so that's going to be negative 1. At pi, you've got 0 divided by negative 1, which of course is 0. 5 pi over 4, they're both negative, same value, so 1. Down here again, watch out, negative 1 over 0, which of course is undefined. 7 pi over 4, same values, just different signs, so negative 1. Back to 2 pi, 0 over 1, which is 0. And as we keep going, of course, these values are going to repeat. Okay, now, I could go and try to graph these, and in fact, let's take a look at what would happen as we do that. I kind of cheated and already drawn some things. All right, at all these values where it's undefined, just like with our secant and cosecant graphs, we need asymptotes. So I went ahead and put those in. So I've got an asymptote at pi over 2, I've got one at 3 pi over 2, and one at 5 pi over 2. So it looks like between each one of these is pi. Okay, and we'll talk about that in just a second. Well, let's go ahead and plot these points that I found and see what happens. Well, at 0, I had a value of 0. Pi over 4 was 1. Okay, then 3 pi over 4 was negative 1. 0, 1, undefined, okay, negative 1, 0, 1, undefined. Okay, so it looks like it's repeating these points between these two asymptotes. It's repeating over and over again the same thing. However, I don't have enough information to know how to connect them. I mean, what's really going on there? How do I put them together? So I think for our beginning, while we're doing it by hand, we need a couple more points. So let's pick up some more of our common angles, such as pi over 3 or pi over 6, and see if we can't figure this out. All right, so I've added to our list down here a few more points. At pi over 6, we get 1 over the square root of 3. Pi over 3 is square root of 3. At 2 pi over 3, we have negative square root of 3. At 5 pi over 6, we have negative 1 over square root of 3. And then 1 over square root of 3, and square root of 3 to finish out the chart. So again, you can do this very quickly by finding those ratios. All right, pi over 6, if you'll remember, is somewhere in here. And it's 1 divided by the square root of 3, which ends up being approximately here at about 0.3. All right, then we had 1, and then at pi over 3, which is on this side, it actually increases to more than 1, so up here. Okay, as we continue to do that, now we've got negative, a little bit past 1 down here. Then we have negative 1 here again, going to be approximately here. 0, and continue the process. And as we graph these points, what we end up seeing is that we do have the same thing repeating, and it's a very gentle curve. So as I connect these, I'm going to connect this middle one right here first. I have a curve that looks something like this. Now, the one thing I want you to notice about this, two things actually, is if I had just started at 0, I'm only getting half of that curve. By starting at pi over 2, I ended up with the entire curve. I can see what's going on here between these. Otherwise, if I start at 0, I only get half of it. Now, what we do commonly in math class is that we oftentimes, to get this first period here, the entire one, we oftentimes back it up and grab negative pi over 4 and negative pi over 2. And when we go to graph, I'll show you one where we do that. That way, I can get the rest of this curve, and I'm not left with only part of it. Okay? All right, the other thing I want to point out to you guys is if you take a look at our graph, it's repeating itself every time from pi over 2 to 3 pi. I've completed one full cycle. So if I do 3 pi over 2 minus pi over 2, I get pi. All right, so what we found was that our period here is pi instead of 2 pi like the other 4 functions we talked about. At this moment, it would be a great time to stop the video and you guys try to graph cotangent again by hand to see what's going to happen with it. So I'm going to give you a few minutes to try that and get a feel for what that's going to look like. All right, welcome back. As you did the tangent function, what you saw, I hope, was that it behaved very, very similarly to the tangent function. Cotangent has that same shape as tangent, but did you notice what happened to your waves here? They reversed. Your tangent came from bottom left and went up on the right. Cotangent starts up on the left and comes down on the right with each asymptote. Also notice with the cotangent, you shifted back from 0 to pi. So all of the functions except tangent, when you're finding those increments and you're trying to graph them, you can start at 0. With tangent, he's the oddball. You really want to back him up and start at negative pi over 2 so that you can get that full cycle in there. Okay, so keep that in your mind. All the rest start at 0, tangent, back him up. All right, so let's take a look at all these pieces and parts of the cotangent and tangent function. All right, so some of the things we've done with sine and cosine and we've used to get secant and cosecant. The first thing was amplitude. Well, obviously, since tangent and cotangent functions do not have a maximum and minimum, there's no amplitude. However, we can still use this number, A, to help us out. If you'll notice on tangent and cotangent, you have a center point that's your intercept, and to the right and left of it, you usually have two other points on our increments. I like to call this the steepness of the graph. That number A in front will tell us how steep to put those second 2 points. Do I put them at 1, or have I got a bigger number? Maybe they need to be at 2 or 3. So we're still going to use A, but again, it's not really the amplitude anymore. Frequency. We said just a minute ago that the frequency is going to end up being the same as it was before. Frequency is the amount of times a cycle repeats within the interval pi. Instead of the interval 2 pi, this time frequency for tangent and cotangent are within pi. So how many times does your cycle repeat while you're within pi units? So the other 4, 2 pi, cotangent and tangent, pi. So our period is normally pi, but we know the same process will apply here that did for our sine and cosine function. To find it, we simply have to take pi now instead of 2 pi and divide it by the frequency. That'll tell you how long it takes for your cycle to repeat. All right, so let's look at a graph and see if we can identify some of these things. You can see that well enough. All right, so I'm going to remark these so you can read them a little more easily. This is negative pi over 8. This is pi over 8, 2 pi over 8, and 3 pi over 8. All right, so let's start off by finding that A value, which again is not amplitude, but kind of the steepness of the graph. So in order to do that, it's going to occur 1/4 way through the cycle and 3/4 of the way through the cycle. So that A value is going to occur 1/4 of the way through and 3/4 of the way through. And if you look at this, if I'm writing a tangent function, I can see that my steepness is 2 because that point, second way through, or 1/4 of the way through, is at -2, and 3/4 of the way it's at +2. And since it's tangent function, it'll be 2. All right, frequency. Well, first I better find the period. The period, of course, I just need to subtract. Okay, 3 pi over 8 minus negative pi over 8. 4 pi over 8, or pi over 2. Frequency, same procedure we've used in the past. Take your period, equal to, now this time though with a tangent function, it's pi divided by b, not 2 pi divided by b. So we got pi divided by b, so b must be 2. Okay, so now we have our A, and we've got our B. All right, let's talk about a couple other things that we've had to find before for our sine and cosine function, and then we'll come back and revisit this guy in just a minute. All right, one thing I wanted you to notice too, again, pointing out about this tangent function is, notice that your x-intercept occurs halfway through the cycle, and on either end of it are going to be your asymptotes. Keep that in mind as we go along. All right, vertical translation. Was this shifted up or down at all? Well, this one was not because my center point is hitting directly on the x-axis, even though it's not well marked. So in that case, it's the same procedure as it was in the past. D is 0. Okay, no shift. The phase shift, okay, obviously something's occurred here because if you'll think back to our normal cycle, if you think where the asymptote was, especially if we're going to use negative pi over 2 as our first side and pi over 2 as our right side, obviously something's been shifted. So how are we going to figure out that phase shift? How far has it gone? Well, different things we can use. My favorite on tan and cotan, or especially on tangent, it's pretty easy. This intercept is normally at 0. So how far to the right has that intercept gone? Well, it's gone pi over 8 to the right. So my phase shift, using a graph, is simply pi over 8 to the right. All right, so let's take all that information that we found and see if we can't write a tangent function for this one. So y is equal to amplitude, which is not really amplitude, steepness, 2 times tangent, I don't know why I put a parentheses there, 2 tangent, and then we need our frequency. And same procedure, leave it outside the parentheses until the end. And then x, we shifted right, so we want minus pi over 8 plus d. D is 0, so I don't really need it. And then finally, if you want to make it a little prettier, y equals 2 tangent, distribute, 2x minus pi over 4. And we're done. All right, let's take a look at graphing a couple of these, and then we'll call it a day. Let's start off with a tangent. All right, we're going to graph 2 tangent x minus pi over 3. And again, it's very similar to graphing sine and cosine. We need all those pieces of information, and we need to know the general shape, which we now do. So we're going to start off by finding that steepness, or A value. And clearly, again, it's in front of tan, so A is 2. The B value. The B value is right here in front of X. Good news is I don't have anything in front of X, so my B value is just 1. Okay, period. Remember, the period is equal to pi over the frequency, or the B value. So my period is just pi. Okay, other thing I want to check at this point is there a vertical translation back here? Did I add anything? Did I subtract anything from the function? And the answer is no. So D again is 0. All right, now what I'm going to do is I know my period. I also know how tangent behaves. So I'm going to find those increments without a shift first. Okay, but this time, since it's tangent, he's the odd guy. Instead of starting at 0 and going 4 up, I'm going to use 0 as my middle point, okay, because tangent is going to fall on either side. So if 0 is my middle point, I'm going to do the same thing I've done in the past. Take your period, divide it by 4. So I am going up by pi over 4. So at 0, the next one to the right would be pi over 4, and then 2 pi over 4 or pi over 2. Get the other side though, instead of continuing to go up, now I'm going to catch it to the left of 0, so negative pi over 4 and negative pi over 2. All right, that way I'll get a complete cycle captured at one time. All right, so the last thing, let's find our phase shift. Our phase shift, of course, is going to be when the value in front of x is 1, which it already is. So this time I've got it made, I can just look here. My phase shift is pi over 3, and it's minus, so that's going to be pi over 3 to the left. All right, so we've got pi over 3 to the left. Now, do the same procedure you've done in the past. I've unfortunately got to subtract pi over 3 from each one of these to figure out where I'm going. All right, so increments. with the shift. All right, so let's go ahead and start negative pi over 2 minus, because we're moving to the left, pi over 3. All right, again, common denominator, negative 3 pi over 6 minus 2 pi over 6. And I am going to get, oh no, wasn't paying attention, guys. Let's check that again. It's minus pi over 3, so I'm going right. Let's fix that. We're going to the right, not the left. That'll make a big difference. All right, so pi over 3 to the right, let's add them this time. Negative pi over 2 plus pi over 3. Find a common denominator. Negative 3 pi over 6 plus 2 pi over 6. So my first value is going to be negative pi over 6. All right, add again. When I add pi over 3 to negative pi over 4, I get pi over 12. And again, you guys, trick, if you go ahead and find a common denominator at this point, I can just count. It's 3 units apart here, so I can keep adding 3. So my next value will be 4 pi over 12, 7 pi over 12, 10 pi over 12, etc. All right, so go to your graph. Let's put those on there, and we're almost home free. I'm going to label in 12ths because it makes more sense. So we're going to label this guy as pi over 12. So back over here, negative 2 pi over 12, and you're welcome to reduce if you need to. 4 pi over 12, 7 pi over 12, 10 pi over 12, and if you want to keep going to get more than one period, just keep going up by 3/12. All right, remember how it behaves. Our asymptotes are on the 2 endpoints, to the endpoints of your increments. So at negative pi over 12, we have an asymptote. And then again at 10 pi over 12, we have a second asymptote. It's the intercept always occurs right in the middle. So I'm going to mark that one. And then the amplitude, which is not amplitude, the steepness here, tells me how high and how low to make my points on pi over 12 and 7 pi over 12, those 1/4 and 3/4 of the way through. So if it's 2, I know tangent goes bottom to top, so I'm going to go down to negative 2 on this side. And on this side, I'm going to go up to positive 2. All right, there you go. That's graphing. Tangent and cotangent is done exactly the same way. Very closely tied to what you have done with sine and cosine. Just go ahead and find those same pieces we've been finding for the past few lessons. Graph them. And again, the hardest thing with tangent and cotangent is knowing whether it curves from bottom to top or top to bottom, the opposite direction. If you forget, no big deal. Pick one point, one of your 1/4 or 3/4 points, put them into the equation, see whether that's a positive or negative number or whether it's higher or lower than the other one, and then you'll know which direction to go. Good luck on graphing your tan and cotan functions.